In this lecture, Professor A.K. Enamel Hawk explains how to measure elasticity of demand and what does it mean.
So now that I'm selling a product, and let's say, so let me summarize it. That I'm selling a product, I have my demand, selling a product A, and I know the relationship. What is the relationship? Price of A, the product, is negative. Price of B, which is another product my consumer consumes, is positive. Price of C is another product my consumer consumes, is negative. Income is positive. What does it tell me as a producer? So remember, this is my consumer. It tells me as a producer, as economy, let's say my economy is going up and the income of my group of customers are going up, I should be aware that there will be more demand for it. Agree or disagree? There will be more demand for my product. So I should be preparing, looking at the income rise of my customers. As their income is going up, since I'm selling a normal product, they're going to ask for more product. Right? We'll come back on measurement of it, but just to look at the notion of it. Second, price of C, which is not my product, but the market for price of C is such that the price of C is continuously going to go down. So if the price of C price goes down, my demand will, what happen? What will happen to my demand? So now I'm not giving any name anymore. So I'm looking at this product, I'm saying price of C, unfortunately, price is going down. Price of C is a different product, not my product. But in that market, for some reason, price is going down. What does it mean for me?
So demand will be high.
Demand will be high. So remember, it has nothing to do with, even if it is complement, is the movement important? If the movement is going up, then it's negative, means I will go down. But I'm giving an example that movement is going down, what will happen to mine? Mine will go up. If my substitute product, another product B, which I'm not producing, their price goes up, what will happen? My demand will go up. Positive relationship. Exactly. So now realize that these three events, I'm assuming three events. What are the three events? My consumer's income has gone up. Income has gone up. Remember, I'm talking about my customers. I'm looking at another product C, with which I have a negative relationship, and their product price has gone down. Price of C has gone down. Now I'm looking at B, which is not my product, but another product, but it's a positive relationship with my product, and B has gone up. All three events lead to demand for A going up. So now realize that how I'm being affected, because these are things that not in my control. I did not even look into that. I did not change my price. But these three events has effectively increased my demand. So realize that my demand increase has a lot of things in it. Now we realize that so far I said is going up, going down. How much it is going to go up? I need to measure them. So we need to think about, how do I measure how much demand will go up? So issue is not demand going up, demand goes down. Because going up may be going up, but is it 10% or is it 100%? If it is 100% going up, it actually means my investment has to double. I need to produce, because I need to produce that product. If I don't produce that product, the market is unfortunately going to be very rude on me, because somebody else will take over my market. So as a producer, I should be fully aware that I should know that how I will behave, and that's why what we need to do, measure responsiveness. So far we talked about, is it positive or negative? But is positive and negative does not really help. I need to know whether it's going up 10% or 20% or what. So that is why we have a concept in economics called elasticity. So let me now explain the concept of elasticity. It's a concept originally came from physics. Okay. So the idea was that it's like think about a rod is elastic or inelastic. If you put a force, what we have?
Sir, elastic.
Elastic. So realize the idea of elasticity
Elastic.
because you can use a force and the rod. So if you put a force here, it will move, it will bend. So remember, the elasticity is actually applying a force and impact on this flexibility of the shape of it, and that's what elasticity. So we said in economics, we are so far talking about quantity, and we are saying price, and we're saying price changes has an impact on my quantity. So this is very much like elasticity. So we said, let us measure elasticity. How do the physicists measure elasticity? So we know that how they measure it. So why should I reinvent the wheel? We can do exactly the same thing. So what we should do, we should find out that what happens if the force changes. So let me draw this diagram a little bit again. So this is my Q, this is my Q, my P, and this is my demand function. So the idea was, if the price changes, previously I was buying here, this is price of 0. Now I'm buying here, price has went up. So as price gone up, my demand has moved from Q1 to Q0 to Q1. I move from point A to point B. So remember, my movement happened from point A to point B, and this is price of the same product. This is A, this is A. So my movement, so this is price of A, and this is quantity of A. A is the product that I'm selling. So if I now look into this one, I now realize that, okay, that basically means that I'm moving from point A to point B. And how did I move? Because I moved because price of A went up and my demand for A went down, right? So if I now start looking at the measurement, I can say, okay, this is the change in quantity and this is the change in price. So I have a very simple logic of it, and we said, okay, how much has happened? That there has been a change in price and there has been a change in quantity. So if I divide them, so I can find the division of it. In other words, I can say, what is the ratio between change in price and change in quantity? Okay, so I can find out this. So let's just assume this is 10, this is 5. So I'm giving a number. Let's say this is 8 and this is 6. So what is happening now mathematically? Change in quantity is went from 10 to 8. So it is 10 minus 8. And how much is the change in price? 5 minus 6. Originally 5 minus 6. What is the equivalent of? This is equivalent of 2 by 1 minus 1, which is equal to minus 2. So we said, okay, this is the change in Q divided by change in P is equal to minus 2. So let me clarify. So change by definition is always new minus original. So I should actually change the other way. So let me do this, correct this. It should be both, because it's always by definition, change is always new minus. So new is what? 8 and old is 10. New is 6, old is 5. Answer is same. This is minus and this is plus. Okay, minus is same, but formula of change is always, remember, new minus old. That is the definition of change, which means if I say change is positive, new must be bigger than old. The change is going down, that means new must be smaller. So definition of change is always new minus old. Have you seen this? So technically what we are doing, this is the change in quantity and this is the change in price. So we're dividing this divided by this, right? If you go back, and since all of you are science students, if you go back to your mathematics, this was x, this was y, and we said this is change in y, and this is change in x. So this is known as slope. So we realize that we are actually measuring the slope. The slope, unfortunately, is quantity dependent. What is quantity dependent? If I look in two different curves and the units are different, slopes are also different. So the problem is, can I make a measurement which is unit independent? Because if I have a measurement with unit dependent measurement has a problem. The problem is I cannot compare, because what is unit dependent? Because there may be per dozen, another price per kilogram. One measurement quantity in dozen, another quantity is in kilogram. So if I have all these, and the products in the real world are all one in liter, right? Another one is in kilogram. So we have all these unit problems. So because we have a unit issue, so we said, okay, can we measure without unit? I cannot compare dozen with kilogram anymore, right? Remember, I say, so if I divide it, it will be, in this case, is like 2 dozens per taka. In another unit, it will be 2 kilogram per taka. Which one is bigger, 2 dozen per taka or 2 kilogram per taka? Which one is more responsive? I have no idea, because they are not comparable. So because of this, we said, can we create an unit independent measurement? And that's where the elasticity as a concept comes. So elasticity as a concept is actually a very nice concept. It's a concept of unit independence. So what is elasticity? So now we go back to the definition. So I'm just explaining why we need. It's actually percentage change in quantity divided by percentage change in price. So that is the definition of elasticity. I am responding in quantity because of changes in price. So how do you define percentage change? Remember, change is change in quantity. Percentage, how do you define percentage? So now the logic, we realize change basically means new minus old. What is percentage change? Percentage change is new minus old divided by old. That's the definition of percentage. Anytime you say, for example, let me go to our last example, it went from 10 to 8. It was 8, and now I'm saying this. So what is, we get the percentage. Remember, this is the percentage definition. Percentage definition, by definition, that you divide with the old. So remember this formula. Don't memorize anything. Formula is this one and this one must be exactly same. Percentage. So this is divided by quantity, which is percentage change in quantity. And if I go to this one, the next one, it will be change in price divided by price. So actually, I have just converted them into percentage. What does it mean? If I reorganize this, I can say this is change in quantity divided by change in price into price divided by quantity. And this is the definition of elasticity. So elasticity has a nice definition, which says this is known as elasticity. And the advantage of this definition, now I can compare oranges with rice with let's say metal or rod, cement. I can compare anybody because this is unit independent. So now we are going to say, okay, we understood elasticity. What is elasticity? By definition, it is change in Q divided by change in price into price divided by Q. That is the elasticity. Now, if you go back to your mathematics course, and I'm doing it because all of you are science students. So this is your X and this is your Y. And if this is your diagram, realize that this is change in Y and this is change in x. Have you seen this before? And we realize slope is equal to change in y divided by change in x. So now I'm asking you to rethink about it. What was the meaning of this? Remember, right now this is what is happening. If I'm looking at this divided by this, right? If I'm looking at this, I'm looking at this particular theta, right? When you say this goes to 0, remember this one goes to 0. What does it mean? It means this distance must become close to 0. So when this distance come to 0, this line will, what happened to this angle? This line will eventually become this, will become tangent, because this line is moving. So remember, as we come closer, we can draw another one. And as we come closer, we'll find out this line will become closer to this. So this is actually dy by dx in mathematics. All it is, this is actually slope, but it's a continuous number. Okay, so remember that there is no difference between this one, and this one. If I now write as a dq by dp into p by q, the only difference between these two is that this is the definition of when price goes from 1 to 2. But when I am using this definition, I'm saying price can go to anywhere, any small quantity can be anywhere. So can the quantity be a continuous number? Can you buy 1 banana and then 1.1 banana? Can you buy 1.1 dozen? Possible. If this is in kilogram, if this is in 1,000 dozens, can you remember? It depends on the unit. So in other words, depends on the unit. Any number can be a continuous number mathematically, right? If I say 1 banana, after that there is no 1 point. But if I say 100 banana, then there is 1.1 exist. It exists because all you have to do defining it. And don't assume that everyone defined by 1 banana. The definition could be 100 banana, 1,000 banana, millions banana. And if there's a million banana, then it is 1.001 is also a number. Good banana, you can still buy it. So we say that, okay, instead of moving to this one, we should move to this one, because this one gives me a much better slope measurement. So we move from previous definition of elasticity, which is this one, which is discontinuous, which is right this one, in fact. Okay, we should. So previous definition, I have just written it here. This was the previous definition of elasticity. We said, no, there is a new definition of elasticity. And the new definition of elasticity is this one. So remember, there is a definitional change in elasticity. And we said, these are the new definition of elasticity.
Please subscribe to this channel to receive updates on new videos.